guys, we're going to be doing or starting chapter 12. This is a pretty easy nothing burger of a chapter, so that's nice. Although it's one of those, like, if you mess it up a little bit, you're going to mess it up a lot of it. So the nice part is most of it is the calculator is going to do the work for us. We just got to know, oh my goodness, what are we doing here, computer? Just got to know what to do. So we're going to start chapter 12 talking about polynomials. So this was something that you guys would have talked about last year in your Algebra 2 class. Sure. So let's start by just kind of defining what we mean by a polynomial function. So we say a polynomial function is just something that can be written in this form. And while that looks like a lot of letters going on there, not totally sure what all that means. So here's kind of the takeaway. These a subs, these guys are just real numbers. With one condition, a sub n can't have a specific value. What value can't the first coefficient have? Anybody with a guess? What would make sense? Yeah, 0, exactly right. That wouldn't make sense because then we could never have like a finite starting point because you always can pick a bigger n and slap a 0 in front of it, right? And then we have these exponents. So these n's in the exponent. What do these n's have to be, the exponents? They have to be non-negative. So 0 is okay. That's the difference between positive and non-negative. Non-negative includes 0. And they have to be whole numbers. So a polynomial is just like the sum or difference, a bunch of like number times variable to a non-negative power. And you can add up and subtract a bunch of those things, as many as you want, as long as it's finitely many, and we'll call that a polynomial. So a little vocab associated with polynomials. If we find the term that has the biggest exponent, we call that guy the leading term. The coefficient on the leading term, we call the leading coefficient. And then the exponent on that biggest exponent we call the degree of the polynomial. So just a little bit of vocab. So to cement this, let's do a couple of quick examples. So I'm just going to give you a function, and we're going to decide whether that function is a polynomial or not. And then if it is a polynomial, we're going to determine the degree for that polynomial and the leading coefficient for the polynomial. So I have 4 functions here, a, b, c, and d. So for A, take a look at that. 4x to the sixth minus 5x squared plus 2x minus 1. Is that a polynomial? Go ahead and shout it out if you know. Yes. Great. What we're looking at is making sure the coefficients, those are all real numbers. The exponents are all non-negative. The only thing going on is addition of terms or subtraction of terms, so that looks good. What's the degree for this polynomial? 6, and the leading coefficient is 4. Everybody's happy with that? Okay. How about for B, the square root of 3 times x minus 6? Is that a polynomial? What do we think? You said no, why not? Okay, you have to be real careful here. Notice where the square root is ending. The square root is not being carried over the x. The square root's ending right at the 3. So this is a polynomial. If the square root had extended over the x, it would not be a polynomial. So we do have to be really careful about that. But since the square root is only involving the coefficient, the square root of 3 is still a real number, so that's fine. What's the degree for this polynomial? 1, very good, because the biggest exponent is on the variable is a 1 on the x. So my leading coefficient then is square root 3. Everybody feel good on that? How about C? Is that a polynomial? No. Why not? Yeah, the square root is over the x is 2. That right there is enough to be like, nope, not a polynomial. Good. What's wrong with D? Yeah, so that's not a polynomial because we have an exponent that's not non-negative. And it doesn't matter that the rest of it looks good. If you got one term in there that's bad, not a polynomial. What do you guys think? Okay with this idea? Remember doing this last year a little bit, I'm sure. Guess what? That was, we have one more idea, and then that's going to be 12-1. The last idea is naming polynomials by their degree. So there's 4 special kinds of polynomials that I expect you to be able to name. So let's just drop this in. So the first one, if we have f of x equals to 0, that is an undefined degree polynomial. And we call that polynomial the 0 function. The next is we have f of x equals a, where a is just any non-zero real number. That's a degree 0 function. So we call it a constant function because there's no variable in there. The next one, f of x is equal to ax plus b. Ax plus b, what does that kind of remind you of? Mx plus b, which is called the slope-intercept equation, right? What do we graph with slope-intercept equations? What does the graph of that look like? Y equals mx plus b. It's a line. Guess what we call those? Linear. So any degree 1 polynomial is a linear function. And then the last one, f of x equals ax squared plus bx plus c. That's degree 2. And we talked about those a lot last year in Algebra 2. What do we call those guys? Starts with a Q. Quadratic, yeah. So again, those are the four that we should be able to like identify by name. No big deal, right? Just a little bit of vocab. We actually didn't do any computation anywhere in there, which I'm okay with, right? What a relief. What an easy chapter or section anyways. It's just all vocabulary. All right. The next thing we're going to talk about is going to be correlation. So in the mathematics sense, correlation is a really specific definition as opposed to the English language sense, right? So the hardest thing or the most easy mistake for students to make is confusing correlation with causation. Let me give you an example. See the stapler here? And we've spent a lot of time in this room. You ever seen a tiger in this room? So it appears that the presence of this stapler is deterring the presence of tigers, right? Clearly the stapler is causing a tiger repulsion field that's keeping all the tigers that would be here away, right? Does that seem reasonable to you? No, that's bogus, right? That would be causation. The stapler is somehow causing the effect. However, go ahead. However, there is a correlation present. The presence of the stapler and the presence of, or the non-presence of tigers is correlated. Those two variables seem to have some kind of relationship between each other, but it's not causal, right? What is the likely reason for there being no tigers in this room? There's no tigers in North America. That's not like an indigenous species. You might find one in a zoo or something, but they're not like walking around. Everybody's okay with that? In the difference between correlation and causation. So correlation, we say, is the nature of the relationship between two variables. So the easiest way to kind of think about correlation is to think about taking our two variables, we collect some data for those two variables, and we're going to plot it. So we'll plot one variable as an x coordinate, the other variable as a y coordinate. So, for example, if I look at this first data set that I plotted, notice that the values, the points, the data points, are pretty closely grouped along one line, right? Those are all pretty close together. Everybody see that? And because this line that I've drawn has a positive slope, we'd actually say this is strong positive correlation. Now, if I try to do the same thing for the other one, the other data set, notice that the points are relatively further away from the line. We'd call that weak correlation because the line has a negative slope. It's pointing down. We'd call that weak negative correlation. So this line that I've drawn in, that I tried to draw as close to all the data points as possible, has a name. We call this the best fit line. And that line just kind of approximates the data set in a linear fashion, right? Everybody's okay with visually kind of what strong and weak correlation look like? Yes?
Does it have to be positive to be strong?
No, you could have strong negative or weak positive. Yep. The positive negative is just telling you kind of the direction of the slope, right? Whether it's sloping up or sloping down. So fairly easy to tell the difference between strong and weak, but could you tell, if I gave you two correlations that were both strong, could you tell which one was stronger visually? That might be tough, right? So what we'd like to do is come up with like a numerical representation for what we're seeing visually. Like a number that describes the correlation. We call that number the correlation coefficient. And we abbreviate the correlation coefficient with the lowercase letter r. Representation. So it's just a numerical representation of the strength of correlation between two variables. So let's talk about the correlation coefficient. What's going on here with this? So the correlation coefficient kind of exists on a continuum. So all values for the correlation coefficient are between -1 and +1. So at -1, we'd have perfect negative correlation. What perfect would mean is that every point in our data set would be points on our best fit line. If it's perfect, all of our data is perfectly linear. So every point on our data set would be a point on the best fit line. And at +1, we'd say the same thing, except it's positive correlation. And at 0, we'll say that is no correlation at all. So for negative values of r, we say we have negative correlation. For positive values of r, we'll say we have positive correlation. And then as we move closer to -1, our correlation is getting stronger. Likewise, as we move closer to +1, our correlation is getting stronger. So we can compare two data sets' correlations numerically really easily, right? We just look at the number, and whichever one is closer to 1 or -1, respectively, then that's the better correlated data set. Everybody's cool with that? Closer to 0, the worse we're getting. So where is kind of the delineation of like what is a strong correlation, what's a weak correlation? I mean, probably if you're, past 0.75 or less than -0.75, we'd probably call that strongish. Obviously, the closer you're getting to 1 and -1, the better. In practical terms, you'd really want to be much closer than -0.75 or +0.75. You probably want to be closer to like 0.95 and -0.95 to really feel good about your data set being linear. But that's another thing. So how are we going to calculate this correlation coefficient, right? We've talked about what it is, talked about what it means, how I can use that number to make a evaluation of my data set. How do I go about calculating it? We're not going to do it by hand. The calculator is going to do this work for us. So let's do an example here. So let's say we have this data set. So this is a data set from like a grocery store or something, and they have like the price they're charging for some canned good and the number of canned goods they sell at that price. Everybody's okay with that? The first thing I'd want to do is identify which one of these should be the independent variable and which one is the dependent variable. So if you're the store that's measuring this, is changing the price causing the number of cans sold to change? Or is the number of cans being sold changing the price? Which one should be affecting the other? Yeah, the price should affect how many cans are sold, right? This is the independent variable for our x coordinate, and the number of cans then should be our dependent variable, our y coordinate, right? If we think about it, if we sell the cans for less, we should expect to sell more of them. If they become more expensive, we should expect to sell less of them. It's a pretty standard, like, economic relationship, right? Supply and demand. Some of us are in econ probably right now. We're like, oh yeah, I remember those words. Okay, so let's show you guys how to do this on our calculator. So I'm going to show you kind of two ways that you can approach this. The first way, we're going to build the scatter plot and look at the picture and just kind of make an evaluation that way. And then the second way, we're going to go and actually calculate the value for R, the correlation coefficient, and make an evaluation that way as well. Everybody's cool? Okay. To do either one of these, the first thing I need to do is to type this data set into my calculator. So if you have a calculator with you, I invite you to follow along. If you want to follow along and you've forgotten your calculator, I have a couple here at my desk. You're welcome to grab one and follow along. You will need to be able to do this in the homework. In fact, this is the majority of the homework is just going to be like using your calculator to do this stuff. There won't be much stuff to write down. Likewise on the test, a lot of the test will just be like putting stuff into your calculator and like using your calculator to do some stuff. So it is real important that you're able to use it effectively. Okay, so the first thing I want to do is type this data into my calculator. The place where I do that is I press the stat button, which is right here next to the left-hand arrow. Inside the stat menu, we're going to pick from the edit tab, we're going to pick the edit command. And I'm going to notice at the top, I have some headings. I see L1, L2, L3. These are the names for some lists that are built into our calculator. I'm going to type my x coordinates into L1. I've done that already. And my y coordinates there into L2. Now, most of us, when we typed or when we went in here, these lists were blank, right? Let's talk about what you can do if they're not blank. So let's say that I accidentally typed in like an extra number down here. Oh no, how do I get rid of the 5? Well, I can just move my cursor onto 5 and press enter, and it deletes it. What if it's like, oh, I have all this leftover data from some other problem I just did. I don't want it anymore. I want to type in some new data. I could delete the data points individually. That kind of stinks. Or if I move my cursor up to the title, and this time press the clear button, and then down, it'll wipe the whole data set for me. Don't press delete. when you're on the L1 or the L2 or whatever. Now I got to retype these in like a dum-dum. Actually, it's not so much a dum-dum. Okay. So I'll pause here and just give you guys a minute for those of you typing stuff in. What's usually a good idea before you finished? Make sure that you have the same number of data points on each column, and then go back through and just double check that you didn't fat finger anything and like transpose two numbers or just type something in wrong or put like an extra zero in or like an extra digit or something. If you goof any of that stuff up, everything afterwards is all goofed up. So stretch your question. Okay. I wasn't sure. Start off looking like a question, then turned into something that looked like a stretch. So I wasn't, just checking. Okay. Got all that stuff in. So I'm going to exit out of here. So I'll press second and mode. And what I'm going to do now is set up a scatter plot. So I'm going to graph these data points. So before I go ahead and build the graph out, I'm going to go ahead and clear out anything that happened to be in my y equals menu. So I'm just pressing y equals, and I'm clearing out anything that might have been in my grapher already from left over from last time I was doing something. Everybody's cool with that? Okay. Next thing I'm going to do is I'm going to press second and then the y equals button. This opens up the stat plot menu. This is how we're going to plot those data points that we just entered in. We have 3 plots to choose from. I'm just going to pick plot 1. I'm going to highlight the on and press enter so that the on is highlighted. I'm then going to choose which kind of graph I want. Well, the first option, the default option, is the one that I want, which is just points. Then I need to tell it where are my x coordinates coming from. Well, I type my x's into L1, and I type my y's into L2. So that's all set. Just hypothetically, suppose I type my y's into L3. How do I change that to L3? If you look above the numbers 1, 2, 3, 4, 5, 6 in blue, you see L1, L2, L3, L4, L5, and L6. So I could just press like second and the number 3. And I could change that to L3 if I needed to. I don't, because I typed mine into L2. So I'm just going to change that back to L2. And then the last one is just what do you want the points to look like? I like the boxes because they're easiest to see. So I usually just leave it on the box default. Everybody so far so good? Okay, so the last thing we need to do before we're ready to graph this is to set our window. The easiest way to set our window is to press the zoom. Oops, we got to exit out of here first. And then press the zoom button. And we're going to scroll down until we see zoom stat. So that's option 9 on my calculator is zoom stat. And we'll press enter. And there's my data set. Your guys' picture should be exactly the same as mine, assuming you typed in all the points the same as mine, and you followed the same steps that we just did. Should get the exact same picture. If we look at this, how's the correlation look? So negative, right? And then strong or weak? Strong. That looks pretty linear to me. Everybody agree? Okay. Let's now exit out of here. And what we're going to do is calculate the R value now for this. Yes, Ryan? Did you press zoom stat? So do zoom and then find zoom stat. Okay. So what the zoom stat does is it automatically changes your window so that it fits the data points that are in your table so you get a nice picture out of it. If you don't do zoom stat, you're probably just going to be looking at a blank screen because you're going to be graphed. Your window is going to be like -10 to +10, -10 to +10, and like none of your data's on there because none of those points are in there. All right, we're going to exit out of here now. So second and mode to quit out of there. And we're now going to have the calculator find that R value for us. Okay? To do this, we have to check one thing first. We have to make sure one option is activated on our calculator. So we have to do this one time right now. And then assuming you don't reset your calculator's menu, or your calculator doesn't run out of batteries, or you don't decide to use someone else's calculator later, you won't have to do this process again. Okay, but we do need to make sure that this part is done for the R values to show up when we run the program we're about to run. So what we're going to do is we're going to start by pressing second and the number 0. This opens up the catalog on our calculator. The catalog is just an alphabetical list of every command on our calculator. The command we're looking for is called diagnostic on. So we could scroll all the way through all the A's and then all the B's and all the C's until we get to diagnostic on. Or notice above the buttons on your calculator in green are the letters A, B, C, D, E, F, G, etc. So the D there is right above the X to the -1. So I'm just going to press that button, and it's going to skip me all the way down to the D's. And now I'm going to scroll until I find that diagnostic on command. So move your cursor so that it's right next to diagnostic on. Everybody got that far? Okay. We're going to press enter to select the diagnostic on command. That's going to paste it to our home screen. And then we're going to press enter again so our calculator says done. Now that we've done that once, we shouldn't ever have to do that again unless we've reset our calculator's memory or our batteries completely die or something like that. But really, we just got to do that one time. Okay? All right. So what we're going to do now is actually retrieve that R value. Now that we've turned the diagnostic on, we'll be able to see the R value when we do what we're about to do. So what we're going to do is we're going to ask our calculator to build a line of best fit. When the calculator does that for us automatically, it's also going to report the R value, the correlation coefficient with it. Okay? So to get that line of best fit, we're going to press the stat button again, right there next to the left arrow. But this time we're going to move over to the calculate tab. And we're going to scroll down and look for the linreg command. Linreg stands for linear regression, which is just a best fit line. Now, if you scroll down and look, you'll actually see that there's 2 linreg commands. I don't know why they do that, but look in parentheses. What's the only difference? Yeah, so in the first one, the A is the coefficient on the X, and the second one, the B is the coefficient on the X, but it's going to give you the same answer. You're just like, which one do you want? The X to come first or X to come second? I don't know why I don't know. Why is there 2 of them? I always just use the first one. And there's no reason not to. Everybody's good? So we're going to press enter there. This opens up the linreg menu. So in the linreg menu, we have 4 things that we have to tell our calculator. The first, it needs to know where the X coordinates are stored at. Well, we had them in L1. Mine already defaulted to L1. It says Y list, we need to tell it where the Y coordinates are stored at. Well, I stored mine in L2 and it was defaulted there already for me. That was nice. In this class, we'll never put anything in the frequency list option, so that should always be blank in this class. The last option the calculator is giving me is to store this regression equation someplace after it calculates it. I'm going to take it up on that offer. What I'm going to do is I want to store this regression equation into one of the y equal spots. So when I go back and I look at the graph, I can see my best fit line in respect to my data set. Everybody okay with that? You don't have to do this, but with some of the things that's going to come after, it's nice to do this, have the calculator do this for us. Because what we're going to do next is going to be using that best fit line, and it's really handy to have it already stored in our calculator. So what I'm going to put here in the store regeq spot is the symbol y1. That's going to be the first equation in the y equals menu. So to get that symbol y1, I'm going to press the vars button right here that's below the down arrow. Vars is just short for variables. From the vars menu, I'm going to move over to the yvars option because we want a y variable. I'm going to pick from the function command y1. Once I have that there, I'm going to move my cursor down to calculate and press enter. So what is all this gobbledygook telling me? Well, it's saying, hey, this is a y equals ax plus b equation. The a is negative 104 and change, and the b is 329 and change. So we have y equals negative 104x plus 329. Everybody's okay with that? And it tells us our r value is negative 0.96. Is that, what kind of correlation is that? Is it strong or weak? It's very close to negative 1, correct? So this is strong negative correlation, which is what we observed from the picture as well, right? When we looked at the picture, looked very much like a line. That line would have had negative slope. That's what we're seeing here from our R value. Is everybody good with that? Let's go ahead and go back and look at the y equals menu real quick. Because I picked to store the regeq, the regression equation, in y1. Notice in y1, the calculator's already automatically put in that equation that it told us about, including all the decimal places. I didn't have to type any of that stuff in. I got it all for free. That's nice, because that was a lot of decimal places to have to track, to write down and then type back in. You know what I'm saying? If I then hit graph, the calculator is going to add in that best fit line for me. So there's my data set with the best fit line on it. Cool, right? So that's how I can get my R value. And in addition, I also get the equation for the best fit line. What can I do with a best fit line? Why bother with it? What is that going to give me? What can I use that to do? Okay, so what you're really talking about is making predictions, right? So you could predict maybe how many cans we would sell if we charged, $1.45 or something, right? Everybody's okay with that? So there's really two types of predictions we can make. One is called interpolation, and the other is called extrapolation. I'm sure you guys talked about this last year in Algebra 2. Do you remember the difference between interpolation and extrapolation? Okay, so that means that we're predicting a value that's in between the points in our data set. So it's inside the data set. So if you picked a value between $1.26 and $2.49, that would be interpolation. And I'm just going to abbreviate data set as just DS. What's extrapolation? Yeah, predicting with an X outside the data set. So for example, you know, $1.45, making a prediction with how many cans you'd sell if you charge $1.45 is interpolation, and predicting the number of cans you'd sell if you charged $1 is extrapolation. Which one of these is going to be more reliable? Which type of prediction is going to be more reliable? Interpolation or extrapolation? Yeah. Why? Mm-hmm. Mm-hmm. Yeah, that's essentially the idea, is that we don't know that this linear relationship is going to continue outside of the data set, right? We just know that inside the data set, it looks pretty linear, but maybe it starts doing something else afterwards. Can you guys think of something in real life that's could look linear for a little while, then stop being linear? How about height and age of a person? Right? If I took a data set of like 5 to 10-year-olds and looked at their height, built a line of best fit and used that to predict the height of a 100-year-old person, what am I going to get? Yeah, like a 10-foot tall person, which we know is patently ridiculous. Why? Because you don't keep growing, right? After like 18, you're done. Does that kind of make sense? That after a while, the linear relationship just stops that we're observing from 5 to 10. It ends. It's over. Does that make sense to you guys? Good. All right. So what do we need to have to make a good prediction? There's two things that we need. Okay. I mean, like, yes, we need data to make but that's just to make a prediction, right? Might still be a bad prediction even if we have data, right? What do we have to make sure that it's a good prediction? Reliable. Good data, okay, which means that we have a good model, right? i.e. that the R value is close to 1 or -1, right? Something where we have a reliable model that we're using to make our prediction with. And then what else? We just talked about it. Yeah, we have to be doing interpolation. If we have both of those two things, we should feel pretty good about our prediction. If we have a good model, if our model has an R value that's close to 1 or -1, and then we do interpolation with that, we should get a pretty reliable prediction. So let's show you guys how to do this with our calculator. Okay? Because we don't want to do this by hand. So let's say that we have this same data set that we've been using. And we want to predict the price or the number of cans sold if we have we charge like $1.85 or something. Everybody's okay with that? There's two ways we can do this. So from our graph, one way we can do this is we can press second and then the trace command. That's going to open up the calculate menu. From there, we can pick the value option. At the bottom of our graph, it's now, you see x equals, and it's a flashing cursor. So I'm going to pick the x value of $1.85 and press enter. It says that we should expect to sell 130, well, let's round that to 136 cans. Second, and then trace, and then the value option, which is option 1. And then I just typed in 1.85 and pressed enter. Everybody's okay doing that? Here's the catch. What if I wanted to do, $3? So I do second, trace, value, and I pick 3. My calculator gave me an error, invalid dimension. Why? Why can't I plug 3 in? Not because we don't have 3 on the table. If I look at my x-axis, it doesn't go up to 3, right? If I look at my window, my x max is 265 or 263 or whatever that number is. So if we're doing some extrapolation, it's a little bit harder to do it using just the picture. Here's our other option for how to do this. And here it doesn't matter what you're typing in. It's going to spit out an answer. Okay? This is, I think, the better way to do it, although it's a little bit more buttons. Everybody's ready? All right. What we're going to do is we're going to retrieve that variable y1. So to get that, we're going to be on the home screen, right? Just the blank screen. And we're going to retrieve that variable y1. So we're going to press the vars button, which is right underneath the down arrow. We're going to go over to the yvars option. We're going to pick from the function. And then we're going to pick y1. And then we're going to put in parentheses, like y1 of 1.85. So you notice we get that same number that we did before from the graph when we did it with the graph. If I press second and enter, it'll give me the same thing I just typed in. So I don't have to go through all those buttons. I can just update it to y1 of 3. And there, instead of getting an error, like I did previously, here I get a value, so about 15 cans. That's why I like doing it this way a little bit better. It's more buttons to press to get to the Y1, but I don't have to worry about like, oh no, is this thing actually inside the window that I have the thing graphed at? Like that's a pain in the tuchus, right? Everybody's okay with that? What if I wanted you to predict what could I charge if I needed to sell 50 cans? So the 50 is a what kind of variable? It's a y variable. So to do that, to figure this out, what I'm going to do is go back to the y equals menu. And in y2, I'm going to type 50. Okay, I'm going to press graph, and oh no, I don't see anything that changed. Where's my horizontal line for y equals 50? Well, I can't see it because the window's hiding it, right? So I'm going to go to the Windows button, and I look at my y min. My graph, or my tables, or my picture starts at 58. That's the smallest y value. Oh, well, I just can't see it. I'm just going to change that to 0 then, right? Now 50 will show up. So let's hit graph now. So here's my line for y equals 50. I'm looking for the intersection there. I might have it, but I might not, right? I can't tell if that's actually crossing or not. It looks like it's pretty close, but I'm going to be sure. So what should I do? I'm just going to make the X max a little bit wider, right? I'm just going to make it a little bit longer so I can see further to the right. So I'm going to change that to, I don't know, 3. And then hit graph again. Now I got it, right? For sure I have the intersection. Do you remember how to find the intersection of two lines? We just did it in last chapter. Second trace, very good. Intersect command. And because all we have are two curves that are only intersecting one time, we can just press enter 3 times. I don't care what any of the options are. So it says for 50 cans sold, I need to charge about $2.67. What do you guys think? I'd round it to 67, right? Round up since it's a 7 afterwards. But yeah, that's it. Notice so far, have we done anything on a calculation on a sheet of paper? Not once. The calculator's done all the work for us, right? So you really need to be able to use your calculator to do this, right? Just get good at it. The homework is going to be very much like this, where there's nothing really to write down other than your answer, because you're going to do it all in the calculator. The test for this stuff, almost nothing to write down. You're going to do it like all in the calculator. Cool? Yeah, basically. Matt, what's up? Certainly. All right, so we're going to stop here. So for sections 1 and 2, you guys should be able to do like 1 through 12. My suggestion to you with, 20, 30 minutes remaining here, get your calculator out, do some of these calculator parts so that if you're getting stuck and you're having a problem, you can ask a calculator expert before you have to go home and struggle bus it yourself. When do we see you guys again? We see you guys Friday? Yeah, so this one will be part of Sundays. I always want to make sure there's a class in between anything being due.